Live from the Icebox Studio in Montgomeryville, Pennsylvania. It's the Bill and Corey Show. I'm Bill.
And I'm Corey.
Welcome back. This is our 38th live episode. So we're doing pretty good.
Yeah, I guess so. We haven't been canceled yet.
We haven't canceled yet? No, we just do the best of. Or something like that. So, we got some good questions this week. Well, we think they're good questions. So we'll see. First one is going to be for Corey for 200. I got a 2210 series regulator. Can I get a brass filter instead of stainless steel? Or are there case reports for use in oxygen? So we got the regulator right here.
And this is a brass regulator, even though it looks like the color is stainless.
Yeah.
But it does have a stainless steel filter, as the question states. And so this person's concerned, I think, and this is what they wanted to make sure it was okay in oxygen, obviously. And this regulator, even with the stainless steel inlet filter, is okay for use in oxygen. But in larger applications, bulk applications where there's 4-inch pipe, 6-inch pipe, oxygen needs to be looked at a little bit closer, and sometimes brass is the preferred metal in those cases. And so I think that person was going with that idea that they would prefer brass. Luckily, there are brass filters that can be put into this. It's hard to do it. You can just get the brass filter and put it in, but it's very difficult to do yourself. So it's something that you wouldn't want to do. So if you would want one with us, you'd have to order a Dash S version, I would have to guess.
Yeah, that's correct. And sometimes it's a preference thing for the brass. Some people just have that. I've had company in the past. We had one customer who wanted everything in oxygen service in Monel. Yeah, exactly.
No, I mean, Monel is the best. It was the best material for oxygen.
Yeah, the stainless steel in our applications is fine. Part of it is due to pressure and velocity. And the filter is...
Yes, velocity is a huge thing too.
And the filter is kind of an important part because that's a point of impingement. So if you have a particle flying along, it's going to hit the filter. And brass is better than stainless steel. But in our situations, it's not an issue in this. Oxygen cylinders are fine for that. Some people have preferences.
Yes, they do. In a previous life, I actually used to have to make cone-shaped filters made of all Monel.
Did you actually make them yourself?
No, I didn't make them. I specified them. No.
Okay. Next one is on... I'm surprised this hasn't come up before. But there was what is a trip point for the excess flow switch? And let me explain excess flow switches a little bit. Excess flow switch it's a switch that tells you when there's excess flow. And why would you use that?
Why don't we name things like that more often? That's the question.
That's pretty simple, but that's what it is. And what you'd use it for, we often sell it with our when we do a 5000 series panel inside of a cabinet. And what you do is you have a excess flow switch like this, and we'll put up the graphic later. So you have a little excess flow switch on the outlet of the panel, and if there's a break in the line downstream, that's what these are really
theoretically there would be excess flow, right?
Excess flow, yes. and which is a bad thing. You have something like ammonia in your cabinet, you don't want that all over the place. If there's a break in the line, this will detect an excess flow, and then it will, then the controller, our GSM-12, will see that, and then it has a little bit of a delay because you don't want to have any chattering issues and stuff like that. So after like a 5-second delay, the ESO valve on the inlet of the panel will shut.
Oh, okay.
So they'll cut. So if you have a gas leak, whatever, a pipe rupture or something like that, it'll shut off the source. And now that's a safety feature you have in there. This is the time you want to put up the graphic for the excess flow switch, the flow graphic. You can see the chart here. I should have had this ready. And these are set up for increasing flow. And there's different. You see. On the right side, you get A, B, C, D. We typically go with the D switch. And now, and you'll see at the bottom it has system pressure, and then you got nitrogen flow rate on the side.
What's the black dot?
The black dot, this was taken out of a catalog.
Okay.
This is we buy this from Switchover, so it's just no big thing to hide.
we don't
It
do we
says
file
Switchover right on the side.
we don't file the VIN numbers off?
No, it says Switchover right on the side.
Oh man.
You're not going to hide that. But it's a very good flow switch. And this is their chart. So the black dot is they explain things in the catalog. But that's at 20 PSI. So you see a band there. So the switch will trip somewhere between 8 liters and like 16 liters a minute of nitrogen. So in higher pressures, it'll be a higher flow rate for it to trip. So it kind of depends. You know, this is the most popular one we do. We have done smaller flow rates. But then you want to use these as an emergency shutdown thing, not as like a process control, because you don't want to be shutting your system down all the time. You get a little tweak of a flow.
Yes. So that range though, so say, 8, you said, what is it, 10 to 16, right?
Yeah, 8 to 16.
Say if it's running at 12 for a while, it might not register it?
No. It will.
Okay.
What will happen is these have normally open, 3 wires in there, common, normally open, normally closed. And then it's set up. Our GSM 12 will see it. If it gets in that zone, if it gets
anywhere in that
excess
zone.
flow, no, it's in that. It's not
okay. So
somewhere in that flow range.
Okay.
It will. It could be 8. It could be 16.
That was my last question. So you could be running at 12 and it not to register, and it won't switch. Is that possible?
Correct.
Okay. Yeah. That's what I'm sorry. That's what
it could be.
It could
12.
But if you go above 16, it's going to be like, you're done. It's over.
And it's probably going to be in that range there.
Okay.
And then, then the controller will see it switches, and then it waits 5 seconds just to make sure it's not just like a jumpy signal, because you could have chatters. If it goes up, let's say you're running in it, you're at 7.8, and it goes up to 8. You don't want it, and then it drops down to 7.8. You don't want it shutting down.
And then there's the ghost in the machine. You never know if something could go weird.
Yeah, just. And we also have the other ones. I might as well show this one too. We get this from AP Tech. So this has welded fittings on here, so it's a little higher purity setup. So we use those too.
It's teeny.
Yeah, it is teeny. That is small, but same kind of thing. They have a floating magnet. It has to be upright, and it has an arrow that says up. You can see it on the camera.
So gravity will affect
it. Actually, you want to take the graphic down now? Okay, great. He already took it down. He's a little ahead of the game.
So gravity will pull it down.
Gravity will pull it down, right. So this will not work in space. So NASA, don't put this in the space station. It won't work properly.
There you go.
Okay. So that's, I think you kind of beat that question to death. Next question is for Corey. You have to put it back together.
Well, I might as well. I want to protect those threads.
Okay, someone's looking for a spec sheet for a 3430A.
And correct me if I'm wrong, but we have graphs for this as well, right?
Yes, we do have graphics. For the first one, you want to talk about where you find it?
Oh, of course. If you go to store.mathesongas.com.
You want to pull up the webpage thing?
Pull up the webpage, and on that webpage, you'll see a blue strip at the top with dark blue letters. Very inspiring choice for colors, if I do say so myself. And it says Help Center, and if you click on that, it's a link.
We highlighted that.
And then you go to the next page, and I'm sure you highlighted the Drawings tab, right? Is there another graph?
Yeah, that's pretty good.
Yeah, very good. And then there's a drawing with drawing underneath. You click on that.
You want to pull up the drawing now? Okay, we're going to pull up the drawing. So the drawing's up there.
The drawing's up there.
Want to see what the drawing actually looks like? And this has...
Yeah, it's got it's a regulator drawing, which you'd expect. It shows you where the inlet is at. It shows you all the different materials being used in it, the specific, inlet pressures, operating temperatures, what the leak test was, how it's clean, pressure rating, and then it has dimensions on it as well, including the different model numbers in the series as well. To let you know what max delivery pressures they have. And so it's got a lot of great information on it.
So what you're saying is the best place for information is on the drawing, right?
Yes.
Okay. This has the most complete information
yes.
on it. You can get information out of our old paper catalog, or you can get it on, or we have PDF sheets of that. And the online store has a lot of information too, but we don't get the online store to the product page. You can drop the.
Also, I want to add.
down.
I also want to add that if you go to the 3430 regulator page, at the bottom of it is also a drawing as well.
Yeah.
So we have our drawings in multiple places, not just the help center.
Yeah, but the drawing is going to have your most detailed information. So if you're really looking for all the particular specs,
How the sausage is made, if you will, right? No, that doesn't make sense.
Not how
That
we
doesn't
make
make
them,
sense.
but it'll just give you all those down and dirty. Like you get the bonnet vent hole port size, or
Or the starboard size.
yeah. Just, okay. Okay. Next question. Customer would like a switchover for a 5 to 10% sulfur dioxide mix. And I'm going to talk a little bit before we put the graphic up. So the sulfur dioxide, you get a few issues with sulfur dioxide. And I think we talked about this a few weeks ago about it. And that was a pure sulfur dioxide. Someone was looking for a pure sulfur dioxide thing. So sulfur dioxide at room temperature has a vapor pressure of 34 psi.
Is that high or low?
That's low.
Okay.
That's low. And our switchover pressure is around 200 psi. And we can tweak that a little bit. But when you do mixes, you can't, people would think you mix, you get 2,000 psi in it, just like a regular nitrogen cylinder or something like that. But you can't, because you can't have a 2,000 psi cylinder in like 10% sulfur dioxide, because the sulfur dioxide will drop out.
Yeah.
So yeah, it just won't, you can't, it just doesn't work that way. You have to, chemistry-wise, it won't work. So when you're doing low vapor pressure gas as minor components in a mixture, there's pressure limits. So we went back to the customer and found out, we said, okay, go find out what PSI your mix is. And they came back at 600 PSI, and then they came back with another mix at 800 PSI. So that was that's not 10%. 10% mix, you're talking 250 PSI, maybe something like that.
Oh, really? Okay.
So it wasn't 10%.
So it's even less then.
Yeah, it was less than that. It's probably like a 5% mix or something like that. So that's something you have to look at is you just don't say, oh yeah, it's a mix, so it's a higher pressure. Nah, you're going to get vapor. You're going to mixes with lower pressures in them. Now the other thing you have to deal with sulfur dioxide is material compatibility.
It's a nasty one.
Yeah. Oh, actually, you want to put up the picture of the switchover? So we're showing a switchover on a rack. We just
on a rack.
You don't need a rack for this one. But we had one. We were doing a job with a bunch of switchovers on racks. I thought it'd be pretty nice to show that. So this is a switchover. It's stainless steel. So that would be compatible with a sulfur dioxide mix. Brass is not.
Opposite of oxygen. Well, I mean, not that oxygen isn't compatible with stainless steel, but
yeah, there's different things. So you need to have it stainless steel. And this picture you're showing, it's a 4-cylinder switchover on a rack, and it's got no manifold, so you just see the 2 hoses on each side, and you strap the cylinders in. People like the racks. I don't know if they're just. I'm thinking, why don't you just, you have to have a wall somewhere. Why don't you mount it against the wall? Sometimes you just don't have a good wall space.
Well, and sometimes maybe it'll be in the middle, of the manufacturing floor, like next to a machine.
Yeah, yeah. But it's also kind of nice. It's a nice little setup. So even if you have a wall, you can go, hey, I got a rack.
They're not that heavy. I hold them up here all the time.
Oh, yeah. But it's got cylinder holders on there, and you mount it nice. True. You don't have to worry about whatever's on the wall if someone's got a window or something.
So Bill, hear me out. I had an idea while you were talking about how it drops below, right? So can we get, how I drink those shakes where you put it in there, you get the ball inside, you put the milk in, you shake it up, and it gets everything mixed. What if we had a shaker, like a little ball inside there in the cylinder, and you shook it to mix the SO2 around? And then would it come out any better?
It'll still drop out.
No, you keep doing it while you take it out.
Actually, what you can, it won't work that way.
I know.
We do sell the cylinder blankets, which
I was wondering if you're going to go there, actually.
Cylinder blankets are made to give a convection current in the cylinder.
That's where I was going to go
And
after
that's for
this
like
one.
a 20 component mixture.
Okay, so that wouldn't work for SO2?
It's not your
Tip, okay.
This is just to keep a multi-component cylinder mixed.
Yeah.
Because you have 20 components in there.
Yeah.
You want to make sure it's...
It's like when you eat your soup and all the salt and peppers at the bottom when you're done. You don't want that.
No, actually, it could be kind of nice. Also, with sulfur dioxide mix, if we're doing a switchover with it, we want to put ethylene propylene O-rings in the check valves, the CGA check valves.
And what was, wasn't the customer
relief
asking for Viton, right?
No.
Oh, that was a different one?
Viton's our normal material.
Yeah.
Ethylene propylene's more better to use for sulfur dioxide. So, yeah, that's all the questions we have for this week.
Yeah.
So yeah, tune in again next Thursday at 10 a.m. for another great episode of the Bill and Corey Show.
Set your VCRs.